Okay, today's video is on compound interest. Um, Now, simple interest simple interest is not um, around a lot, in the real world. Simple interest only calculates interest based on the initial amount that you put in. For example, if I put in $500 at a certain interest rate, uh, then it's going to calculate it, as far as the interest, but it only calculates the interest based on the initial amount that you put in. So as your money grows, it's still going to calculate interest on the original amount. I don't know if that makes any sense. Um, but basically, simple interest is going to, over a period of time, let's say 5 years, is going to calculate interest. But as the money and the interest grows in the account, it's still only going to calculate the interest for the original amount. So then that's where compound interest comes in. Compound interest calculates interest um, calculates interest as the money grows. It calculates new interest every single time based on the new amount that's in the account. And this is actually more prevalent in the real world. In the real world, almost everything uses compound interest. Loans, car loans, home loans, personal loans, credit cards, um, you know, department store cards. I mean, any time when you're dealing with loans and interest rates, I would say 90% of them use compound interest to calculate the amount in the account. Now, compound interest, um, you can compound it however you want. You can compound it, every week, every day, every month. You can calculate it every single minute if you wanted to. And that's the really sort of universal thing about compound interest. So the definition of compound interest is interest calculated compound interest is interest calculated on top of other interest. I should say previous interest. Trying to find another way to word that, but basically, when you compound things, you build on top of them. So, for example, if I put money in an account, $500 in an account over a period of years, and it's made $100. When my account goes to compound the new interest, it actually will include the new money that I've made. And so you can actually build more and more and more and more money in the account faster and faster and faster, because there's more and more money going in the account, whereas simple interest just keeps doing the original, the original, the original, the original. So you gain the same amount every single time. So again, compound interest can be calculated in various time frames, from yearly to monthly to even by the minute, which is crazy. That doesn't really happen. Most compound interest does it daily. So every time it calculates, it takes into account the new balance of the account. The most common compounding is daily, which I just mentioned. Your mortgage, car payment, and personal loans all calculate interest daily. This is why it's important to make payments on time, because the money in the account grows. You don't want your debt to grow. That's why it's important to make your payments on time. By making your payments on time, you ensure that you're going to pay it off in a timely manner. If you are late with your payments, those days that it's late, because it calculates interest daily, you're owing more money by paying it late, which is often a problem people get into. So it's important to be on time when you're making your payments. So there is a formula, just like the simple interest formula. Compound interest has a formula as well. The compound interest formula is, we'll call it A for the amount in the account. A is the amount of money that is in the account after you calculate this. So A equals P times 1 plus R over N times the NT power. So complicated formula here, but really all it is just plugging in a bunch of numbers. So again, you have A, which is going to be the amount in the account after you've compounded the interest. P is the same P from before. It's principal. It's the amount of money you started with. 1 plus R, which if you look down here, actually I'll scroll down so you can see this. R, hey, is your interest rate. Remember that it's expressed as a decimal. So if it's 5%, it's not actually 5. It's 0.05. N, this is a sort of tricky one here. N is the number of times that it would be counted in 1 year. For example, if it is compounded weekly, then your N would be 52 because that's how many times it would be compounded in 1 year. If it was compounded monthly, then your N would be 12 because it's compounded 12 times in 1 year. So that's what the N is. It's how many times you're going to actually calculate the interest in 1 year. So most of them are daily. Most accounts are daily. So your N would be 365 because that's how many times it's compounded per year. It's every day, so 365 days. NT is time in years. So really this lesson here, all it is just working with the formula and calculating the compound interest formula. And we're going to spend some more time on this next class too. So if you're a little confused, don't worry, we'll hit it again. So the question here asks you, why would it be beneficial to make payments towards your loan early? There's obvious reasons why you want to pay your loan early. The earlier you pay it, remember, interest grows. In most accounts, it grows daily. Every single day that account is calculating interest. So if you can pay it off even days early or months early or even years early, you're going to pay less in interest, and you're going to pay actually less for whatever it is that you purchased. So it's important, if you can, to make those payments early. That way you don't calculate as much interest. So let's look at an example where we can use the formula to compound interest. So the first one is Rico here. Rico deposits $800 at 3.87% interest, and it's compounded quarterly. What is the ending balance after 1 year? So we're going to use the formula. So the formula is A equals P times quantity 1 plus R over N to the NT power. And we're going to plug in everything that we know. Well, the amount is what we're looking for. What's the ending balance? So P is principal. It's what I started with, which is right here. My pen's sort of large. That's where it is. It is $800. Oops. Let's try that again. And then parentheses 1 plus R is my rate as a decimal. If you don't know how to do that, just take the rate of 3.87 and divide it by 100, and that'll give you the decimal form. 3.87 as a decimal is 0.0387 divided by how many times it would be compounded per year. Since it's compounded quarterly, think about quarters. How many quarters in a dollar? That's how many quarters are in a year. So quarterly is 4 times a year. So my N is 4, parentheses, same N. These N's right here and this n right here are the same ones, so it's 4 again. And time is 1 year, so it's just 4 times 1, which is, we do 4 times 1, which is just 4. So the first step, there's a lot of numbers in here, and so how do you do this? You can use your calculator to do this and put everything in, but basically what you want to do is you want to do this part first. Okay, what's inside of the parentheses. So you can do 0.0387 and divide it by 4 and then add 1. So I'm going to take out my calculator here and do 0.0387 divided by 4 equals, and then add 1 to it. And I get 1.0096. Basically, I get 1.01. So what this is now A equals 800 times 1.01 to the 4th power. Again, you can write this right in your calculator, but if you're not using your calculator, one of the calculators at the table, you need to understand your order of operations. Be careful. You cannot do this times this first. Order of operations says exponents first, so I actually have to do this first, then multiply by 800. So I'm going to take 1.01 and then do that to the 4th power, and then multiply by 800. And the amount, the amount in my account is $832.48. Stop, pause the video, rewind. If you don't know how I got that, go back and rewatch that section. That is absolutely as easy as the compound interest formula goes. Okay, let's look at the next problem. Here we are, Nancy here. Nancy deposits $1,200 into an account that pays 3% interest, and it's compounded monthly. So what is her ending balance after 1 year? So again, we're going to use the formula. So again, I'll write it right here. A equals P 1 plus R over N to the NT. Now I'm going to plug all the values in. I don't know the amount. That's what A is. That's what it's asking me for, the ending balance. So P is principal. That's what I started with, which is 1,200. Parenthesis 1 plus my rate as a decimal. So it's 3%. So that is 0.03 over how many times is it compounded per year? Since it's compounded monthly, that is 12. And then this is the same end here, and then this is after 1 year, so times 1. So again, you're going to want to do what's in your parentheses. You want to do actually this first. So we can type that in our calculator. 0.03 and divide it by 12, and then add 1 to it, and I get 1.0025. So what this is A equals 1,200 times 1.0025, and 12 times 1 is 12. So again, we have to do this part first, the exponent part first. So I'm going to do that to the 12th power, then multiply by 1,200. And it looks like the amount that would be in my account is 1,236.50. Again, if you didn't get that or you lost yourself in that problem, please pause the video, rewind, and go back. Okay, a few more. We get used to this here. all it is with this is just practice, practice, practice. So I'm going to keep this up here because number 3 involves number 2. Nancy receives 2 offers in the mail from other banks. One is an account that pays 2.78% compounded daily. The other one is 3.25% compounded quarterly. Would either of these accounts provide Nancy with a better return than her current account? So what we're going to do is we're going to look at 2 different banks coming in, and they compound things a little bit differently. And you're going to see if she had invested her money in a different bank, if she would have made more money. So there's actually 2 parts to this question. So we're going to use the same formula as we did above, but now we're going to use a different interest rate. So it's still going to be the 1200 times P, oops, I'm going to do that times a 1 plus my rate. We'll do the first bank, which is 2.78. As a decimal, it's 0.0278. Over, and that one was compounded daily. So how many times is it going to be compounded in 1 year? And daily, there are 365 days in a year, so it's going to be compounded 365 times. That same number goes up here, times the amount of years, which was just 1, so times 1. So we're going to do what's in the parentheses first. Okay, and hopefully it's not too hard to see. But, so I get A equals 1200, and I'm going to do, so 0.0278 divided by 365 plus 1 is a very small number, and I'm going to write it until I get an actual digit here. So 1.12348 to the 365th power. Again, do your exponent first. So 1.00008 to the 365th power times 1200. So with the 2.7% interest rate, I will have $1,235.56. Now keep in mind, I mean, that's pretty close. I mean, that's only $1 off, but it was a lower interest rate, so not too bad. So now I'm going to do the exact same thing. Actually, why don't you do the second half on your own? Pause the video, do the second part of this question, and then play it to check your answer. So here is the answer. You got $1,238.86. So it looks like she would have made slightly more money by going with the account that paid out at 3.25% compounded quarterly. So there's the work. It was 0.0325. That's 3.25 as a decimal. It was compounding quarterly. So that's why this is 4. And did all the math there and came out with that. If you don't know why I got that, please watch the first 3 problems again to see how you get that answer. So, I don't know why that is staying there. But let's see if it'll let me. Here it goes. Okay, I guess apparently I have to erase that now. So example 4 says Marie deposits $1,650 for 3 years at 3% interest compounded daily. What is her ending balance? It's the exact same thing, except now it's for 3 years. So I'm going to let you figure this one out on your own. Pause the video and then do the work, and then return to the video when you are done to check your answer. So there is the answer to that particular question. Just to kind of go through it real quick, it started out with 1650. 1 plus the interest rate is 3%, so that's 0.03. It's compounded daily, which means 365 times. Same 365 times here, and this is over a course of 3 years, so you had to multiply it times 3. I did this part first inside the parenthesis. I got 1.00008. You want to go as far as you can till you reach another number in the decimal, just because it makes it better for rounding. And then I took the exponent. 3 times 365 is 1095. So I did this part first, then multiply by 1650 to get 1801.05, which means that she earned about $150 in interest over 3 years. Last question. Kate deposits $2,350 into account and earns interest at a rate of 3.1%. Compounded monthly. What is the ending balance after 5 years? So, pause the video, try this problem, check back to check your answer. There you go. There is the answer to the final problem. She started with $23.50. The interest rate was 3.1%, so that's 0.031. It's compounded monthly, meaning you divide by 12. That same 12 goes here, and it's over a course of 5 years, so that's why T is 5. Did this part first in the parenthesis, got 1.003, and then 12 times 5 is 60. And then did the exponent first, multiplied by 2350, and got $2,812.70. I mean, essentially she made $462 in interest over the course of 5 years, which is pretty good. So that's that. You do have an assignment. There is an assignment that is required for you to turn in if you want mastery on these particular outcomes, which were outlined at the top of the paper. If you do the work and you submit the work in through Canvas, I can check it, and you can earn mastery on these assignments even though it's not on an outcome quiz. I'm giving you a gift here. You have an opportunity to work in class and work with people and work with friends or whatever and get it done correct and check your answers. Okay, I need to see the work. You will not earn mastery if I don't know how you got your answer. Okay, so you must show your work. If you get everything right, and then you can earn mastery on those outcomes. So you need to do the work. All right, thanks.